Hey guys, okay, so here we go. The first question, you have to look at the graph. Okay, so it's true or false. So the Garcia family is going on a road trip. It says these are the hours driven. So your x variable, your x is 6, 5, right? What are they measuring? They're measuring hours. Okay, and then on this side, what is this side measuring? 230 what? 20 what? Miles. Okay, so the variables are hours and miles. The Garcia family is going on a road trip. Above is a graph showing how far they've driven after each hour. Use the graph to determine if each statement is true or false. So let's go see. The number of miles driven increased between hour 2 and hour 3. Now, 2 and 3, that's here and here. Did it increase? Nope, false. Okay, next one. The miles driven increased between 3 and 5. So 3 and 5. Between 3 and 5, did they increase? That's true. The number of miles driven stayed the same between 5 and 6. So 5 and 6. Yep. Oh, wait. Did it? Oh, it stayed the same. See? Constant. So that's true. Okay, next one. Remember that there are more practice problems in Google Classroom, okay? In Google Classroom. Remember there was 4 of these? You got to click on the doc, the Google Doc. All right. Angel is shown the graph below and has to write an equation to represent the line. Remember, eliminate. Eliminate to increase your exceed chance, okay? So here we go. What can we eliminate? First of all, let's look at this. What's your y-intercept? This is where the line crashes into the y-axis. Okay, so where is your y-intercept? Your y-intercept is right here. Right there. Alright, so at 2, so 0, 2, you know that when x is 0, right, your y-intercept touches the y-axis. So go look over here. Is that a y-intercept of 2? No. Eliminate. Okay, this is a y-intercept of 2, so this one's good. Y-intercept of 2, that one's good. Y-intercept of 1/2? No. Right? So look, you have a 50% chance of exceeding the standard just by, right? Like this is gone. And then what's gone too? So this is gone. And this is gone. All right, so now can we look at steepness? So look at the steepness, right? So remember, if you drop a little roller coaster from left to right, right? If I just drop the roller coaster, it's going to land here and it's going to go what? Up. So this is increasing, right? It's not an N, it's not a negative line. So if it's increasing steepness, you can go eliminate steepnesses, slopes that are negative. That's a positive, so that one's good. Boom, right there. A negative slope means that it should be going down. Nope. Nope, 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 nope. So you can eliminate, right? So that's gone. And look at that. You got the answer just by eliminating the wrong steepness and the wrong y-intercept. But let's check this out. This is a change in y, right? A change of y. That means you got to increase by 1. And this is your change of x. Go to the right, 2. So let's go see if that's true. From here, that's 2, and here is 3. So remember, if you need to pause or rewind, go ahead. Be careful tomorrow. You're going to count your rise from here to the next number. So Wasn't it 1 over 2? All right. Your change of y is 1. And then what about your change of x? 1, 2. Count hills tomorrow. So, yep. From one point to the next, rise 1 over 2. That is correct. Okay, next one. Next slide. All right, this one. The table shows the linear relationship of the cost in dollars of buying a bag of Takis and the number of bags purchased. I wonder if I can rotate this. Okay. So is there a relationship between the number of bags and the cost? So a linear relationship in the cost in dollars, and it's telling you that's your y, that's your output. So you know that these are y's, right? And they tell you right here, they gave you a hint. So of buying a bag of Takis and the number of bags purchased. Look at what the variable they gave you, x. Okay, so these are x's. All right, let's keep on reading. What is the unit rate? Unit rate. They didn't say create an equation y equals mx plus b. They didn't say what is m equals. They said what is just the unit rate. So don't get all level 5, right? When it's just asking you for the rate. So let's see. What is rate? Isn't it slope? What is rate? Isn't it the change of y over the change in x? Right? That is rate. So I want to know how many dollars per bags. So here we go. What is your rate? How did your y increase? That's called your change in y. How did it change? You went from 3 to $4.50. So you're going to have to do some subtraction, right? $4.50, take away $3. That's 0. That's 5. Drop your decimal. 4 take away 3 is 1. $1.50. Now, is it per bag? Let's check. What was your change in x? Because aren't these x's? So what was your change in bags? Oh, for every 1 bag. So there it is. What does this mean? It's $1.50 per 1 what? Bag. So tomorrow, a good answer would be $1.50 or $1.50 or $1.50 over 1. Okay? These are all good answers. So tomorrow, right, if you have like, $2.70, right? And your next one is $3.60, right? What was the change in y? Well, don't you have to subtract $3.60, take away $2.70 to find out the difference, right? Did it increase? Yup, it increased. By how much? 90 cents. Okay? So, moving on. So tomorrow, only that answer, okay? Or this one, or this one. Alright. Michael claims that y equals 2x cubed plus x squared is a function, but not a linear function. What makes his claim true? Not a linear. What does that mean? That means not a straight line. Okay, so we don't care about all these. All we care about is we know that that's not a straight line. How do we know that? Because you know the equation, y equals mx plus b. Your equation should look like that, right? Y equals maybe 2x plus 3, right? That's a straight line. You know that. The exponents makes it not be a straight line. All right. What is the equation in the form of y equals, that's supposed to be an equals form, in the form of y equals mx plus b? That respects the function described by the graph. Reflect, not respect. Anyways, First thing you need to type is y equals mx plus b. And then you're going to delete, right? Delete your b. And what is b? B is your y-intercept. Now check your grid. 0, 1, 2, 3, 4, 5. So you're actually counting the units. So where is your y-intercept? Your y-intercept is where x is 0. Do you see that? And how much did you go up? 1. So that right there, the 1 is called your b, your y-intercept. So I'm going to put a 1 right here. So you're going to type y equals mx plus 1. Now, I got to find m, don't I? Well, what is m again? M is a slope, and slope is a steepness. And how do you get a steepness? Don't you have to have 2 points? And so, how do you measure that steepness? How did your y change? And how did your x change? So, let's come back over here. I need to find out what is my change in y over my change in x from one point to the next. Let's go see. Alright, first of all, ready? You need 2 perfect points, so be careful. Boom, here's 1. Follow, 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 follow. Why would you stop there? Let's just say you did. A lot of people did. What was your change in y right here? Can you measure that perfectly? Sure. You went down 1. So your change of y is down 1, right? Your change in y equals down 1. Alright, but what's your change in x? What is this measure right here? Is it 0.4? 0.6? 0.5? Like, you can't tell. So why would you stop there? Just because there's a point? So here we go. That's not a good spot to stop. Follow, 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 follow. Boom, right here. Do you see how you get that little cross section? You want to stop there because check this out. You can go from this point. How do you get to this point? You go down 1, 2. So your change in y is down 2. But then, can you count perfectly? Boom, right there. How many units was that? 1 to the right. So that's your answer. It's -2 or down 2 to the right 1. And isn't that what slope is? Down 2 over 1. So then over here you would delete your m and you put down 2 over 1. And that is your answer. Y equals -2 x plus 1. Do you need the 1? No. Could you put it? Yes. Okay? So this is a good answer, or y equals -2x plus 1 is a good answer, okay? Alright. Pause if you have to. Rewind if you have to. Review. Remember, in Google Docs, there's in Google Classroom, you click on the Google Docs. I gave you 3 examples of these kind, okay? Alright, next one. Oh man. Okay, so here we go. This table of values represents a linear function, so it means that it's a straight line. And it's a function. Every input has a unique output, right? Alright, that's what linear function means. Enter an equation. Boom, right there. You're going to stop and you're going to literally enter your y equals mx plus b. Alright, cool. And then you can't leave it like that though, right? Like, you gotta delete your b. Now, where's your y-intercept? Isn't the y-intercept where x is 0? And then that gives you your b? Because that's the only way, right, that you can touch the y-axis, is if x is 0. So, where do you see a 0 comma, negative b, or b. Right here. See, aren't these ordered pairs? So, if this is x, what is your b? Negative 2. So, I don't want you to put plus minus 2. Yeah, let's not do that. So let's just put minus 2. Alright, let's go over, leave your x. But we got to go find m. Remember again, m is a slope. And a slope is a what? Oh, it's a steepness. And how do you say steepness? Change of y over change of x. It's a steepness between 2 points. Alright, let's go find your change of y. So here's y. How is y changing? Be careful here. Is it increasing or decreasing? So you went from negative. So draw a number line if you have to. You're at negative 2, negative 1, 0, 1, 2. Watch. From negative 2 to 0, negative 2 to 0. You got more what? Positive. And you increased by how much? 1, 2. You increased by 2. Good. Now what's your change in x? How's your x changing? Well, let's see. Here's your x. And how did it change? You went from 0 plus what is 8? Plus 8. So there it is. Your x changed by adding 8. And your y changed by adding 2. It's not decreasing, it's increasing. This is a good answer. Leave it. So you're going to go back to your equation. And you're going to type 2 over 8. And if you know how to reduce that, great. If you don't know how to reduce that, leave it. Alright, just in case you want to review reducing. Divide by 2, divide by 2. Find a number that they have in common, 2 and 8. Well, they have 2 in common. So what's 2 divided by 2? 1. What's 8 divided by 2? 4. This is your reduced, simplified form. So, y equals 2 over 8x minus 2. That's a good answer. Y equals 1/4 x minus 2. Good answer, good answer. Okay? So, make sure you put that in there. Because this is the same thing. It's reduced. Alright. Be careful. You're looking for less than 10, equal to 10, or greater than 10. Let's go look at our story. Number of tacos sold. So this is number of tacos. The variables, 20, 15, 10, right? What are those numbers? Tacos. Alright, next one. 5 what? 10 what? 15. What are we measuring? Oh, dollars. Okay, so this is dollars. So here we go. How do you do this? Let's go see. The money made by selling 10 tacos. How much money did you make? So I want to know how much money did I make when I sold 10 tacos. So you have to go to the number variable they gave you. Okay, look for the unit. So for example, watch. Money made by selling, alright, what's the number? 10 what? Tacos. Go to the tacos and go find 10. There it is. Now, remember these are relationships. 10 relates to who? 10 relates to 15 tacos. $15. So 10 tacos relates to $15. So the money, $15, is that less than 10, equal to 10, or greater? Greater. Alright. The number of tacos sold when at 15 what? What's your unit? Dollars. Go look at that variable, dollars. Okay, wasn't it that side? All right. When it's $15, how many tacos? Oh, 15 relates to 10. Is that less than 10, equal to 10, or greater than 10? It's equal to. Oops, my bad. Okay. All right, next one. The average money made, so you're looking for the money for selling 4 tacos. Where's 4 tacos at? Right? You have to go to 4 tacos. So go to the number 4. There's 4. And we're going to find what it relates to. Boom, stop right here. Okay, so that's 10, 11-ish, right? 12 is right here. So is it less than 10? Nope. Equal to 10? Nope. Greater than 10. So when you bought 4 tacos, it was about $11, $12, right? Because you want to know the average money. So the average money made for selling 15 tacos. So now you're going to go to 15 tacos. Okay, 15 tacos. Where's that? Here's tacos. Here's 15. What does it relate to? Stop right here. 15, 16, 17, 18. So 15 tacos relates to 18 what? Dollars. Is that less than, equal, or greater? It's greater. Alright, so if you need to review this, push pause. And remember, check out Google Docs. There's more examples on how to do this. You're looking for the relationship between your input and your output. You have to look at your you have to look at your unit. So 15 what? Tacos. 4 what? Tacos. So you're going to start over here. Or if they say number of tacos sold when at $15, so go to $15 and then see what it relates to. Okay? All right, that's that. We're almost done. All right. So, blah, 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 right? Blah, blah, blah. Enter the equation that shows x as the person and y as centimeters. So, enter the equation. What should you do? Y equals mx plus b. Okay, so y equals mx plus b. Now I gotta go find my y-intercept, right? My y-intercept, isn't that where x is 0 and y is a number? Alright, let's go look for it. 1, 2, 3, 4. There's no 0. So we have to find the y-intercept. So we gotta find b, right? I gotta find b. And then I also have to find what? M. So let's go ahead and start with M. What is the slope? And remember, slope is the same thing as what? Steepness. And what is steepness? The change in y over the change in x. So here's x for persons. They told us that, right? And here's y for centimeters. See? Y centimeters. X is the person, the people. Alright, so let's go find this change of y. What do you notice between going from 8 to 7? Did it increase or decrease? Decrease by 1. Decrease by 1. Alright, cool. Moving on. What was your change in x? How did your x change? From 1, now you have 2. It's an increase of what? 1. Boom. There is your slope. So you can actually go over here now and we can delete the m because didn't you find it? It's down 1 over 1. Cool. We can leave it like that. That's a good one. But now we got to go find b. So check this out. Now that you know the change in x, right? Aren't you increasing by 1? Increasing by 1. All right. Let's go backwards. So I'm going to use a different color. Instead of increasing by 1, let's go backwards. Decrease by 1. Decrease by 1 gives me a 0. Cool. So now we're almost at b. We can find b. So let's see what the pattern is here. If I decrease by 1, decrease by 1, how can I get back? Oh, I got to increase by 1. Increase by 1. See? You went from 6, now you're 7. Increase by 1. There, increase by 1. So can you give me one more increase? What is this b going to be? A 9. So you just found your b. And it's 9. Because remember, you're looking for that 0. That is your evidence that you have a y-intercept. Alright. This one I'm only going to show one. We did it in class. It's that one and this one. So here's your equation. Y equals 2 over 3 x plus 2. Okay, so we know that this is y and we know that this is x. So then, here we go. Here's your y. Oh, my bad. Here's your x and here's your y. So substitute. If this is y, put a 4 here. Placeholders equals 2 over 3. Placeholders. What is x? X is 3. And then you add 2. Alright, let's do the math. Whatever you don't use, you have to bring it down. Now, you can't multiply fractions without denominator. So here we go. Divide by 1, which is totally okay, right? Now you have to multiply. What's 2 times 3? 6. Keep your division. And then what's 3 times 1? 3. So multiplying fractions, literally you just multiply numerator with a numerator and denominator with a denominator. Bring everything down that you didn't use. Almost done. 4 equals 6 divided by 3 is 2 plus 2. So what does that say? 4 equals 4. Is that true? That is a true statement. That means you did your math right. That means that when you put the point into the line, it fits. So 3, 4 satisfies y equals 2 over 3x plus 2, which means there's your line and your point is on the line. So this is a good one. This one is not. That one is not. Functions. What is a function? A function says that each input has only one output, right? You can't repeat your x's. If you repeat your input, you better have the same output. You can't have 2 outputs for the same input. Okay? So you got to look at same input. Is that a same input? Nope. So, is this a function? Yes. A, what does this say? Right? What does this say? This is an ELA, right? What do we say that this is? It's a line. Alright, cool. Look at the line. Vertical line test. Boom. How many times did it touch? Once. 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 So is a line a function? Yes. That's a function. Okay, let's check this one out. Is this a function? Vertical line test. Oops. Aye. Vertical line test. It touches there and there. This is not a function. You want to know why? Because, let's say for this one, x. When x is 4, who does it relate to? Right here. It relates to this output. But then hold on. X also relates to who? This output. Okay, so positive 2, let's just say. And this is what over here? A little more, like 2.5. So 4 relates to 2, and 4 relates to negative 2.5. Same input, but you have two different outputs. So this is called a vertical line test. When you do a line, it can't touch 2 times. So here we go. Let's do it again, just in case you didn't understand that, or just rewind and look at your notes. If I do a vertical line, it touches 2 times, not a function. Alright, you can't have 2 different outputs for the same input. Any same inputs? Nope. Every input has an output. Every input has an output. Okay? This is a function. And then I'm going to ask you, hey, is that a function? What if your line looked like that? Is that a function? No, because if you do a vertical line test, it touches there and there and there and there and there. So this is not a function. It fails the vertical line test. Alright. Next one. Okay, this one is the same thing. It's substitution. Do you see an X? Yep. Do you see a Y? Yep. And then so isn't this an X? And isn't this a Y? Pick easy values. So here we go. Y equals 4x minus 10. Y is 3, so 3 equals 4 times x minus 10. What is x? 5. Right? I don't know why I used purple, guys. I'm sorry. Alright, so let's see if it's true. 3 equals, what's 4 times 5? Well, that's 20 minus 10. 3 equals 10. That's not true. This is not it. Okay, next one. You gotta try them all out. Y equals 4x minus 10. Here's y. Pick easy numbers. 0 equals, isn't that your y? There's your x. 4 times what? 5 minus 10. 0 equals 20 minus 10. 0 equals 10? Nah, not that one. Alright, one more. Okay, I guess I can't undo that. You can rewind. Alright, next one. Y equals 4x minus 10. Y is 6. Well, I'm going to go with 10. These are easier numbers. So, 10. X is 5. So, equals 4 times what? Minus 10. What was x? 5. Let's see. 10. Bring it down. If you don't use it, bring it down. 10 equals, what is that? 20 minus 10. 10 equals, 20 minus 10 is 10. Check. This relates to that equation. Okay, you got a true statement. And these ones, same thing. Okay, I don't know, okay, so y equals 1 over 3. It's okay to have fractions, right? Plus 5. Now, we don't need the y. We're going to substitute. So, here's your x. Here's your y. 0 equals, what's your x? Negative 6. Put a negative 6 there. And how can you multiply fractions? Oh, you got to put it on top of a 1. So, 0 equals, bring it down. 1 times negative 6 is negative 6. 3 times 1 is 3 plus 5. Be careful. 0 equals 6 divided by 3 is 2, negative plus 5. 0 equals Do you have more positives or more negatives? More positives. This is not true. This point does not satisfy. Next one. Y and x. Okay, write the equation. Y equals 1 over 3 times 6 plus 5. Okay, what was y though? Y is 7. Let's see. Bring it down. 7 equals, okay, what's 1 times 6? 6. What's 3 times 1? 3 plus 5. Alright, let's simplify. 7 equals, bring it down. 6 divided by 3 is 2 plus 5. Hey, 7 equals 7. This does satisfy because we got a true statement. That means that this point is in the line. See? So like all overs that satisfy. Alright. Y equals 1 over 3 x plus 5. Okay, we don't need y, we don't need x. We're going to substitute for y, and you're going to substitute for x. So what is y? 7. What is x? 6. Alright, clean it up. 7 equals, what's 1 times 6? 6. What's 3 times 1? 3 plus 5. 7 equals 2 plus... Oh, I did that same one again, guys. Wrong numbers. Y and x. There we go. 10 equals negative 12. All right. 10 equals 1 times 12 is negative 12. 3 times 1 is 3 plus 5. 10 equals, what's 12 divided by 3? 4 negative plus 5. That's not going to equal. This is not an answer. Okay, and this one should be an answer. So this is y. That's x. So here we go. 6 equals 1 over 3 times what? 3 plus 5 over 1. 6 equals 3 over 3 plus 5. 6 equals 1 plus 5 because 3 divided by 3 is 1. And 6 equals 6. Yep. So this is a solution and that's a solution. Alright guys, you should be able to do this one. Okay, be careful with your negatives. Alright, that's it. Don't forget to check out Google Docs. You do not have to finish tomorrow. You could stop at 5 or 6 problems if you want.